Here is the question like this. Siam and the co produces three variants varieties of the certain product: deluxe, fine, and ordinary. The recent market survey is conducted for the prevalence of product. The reference was found as follows: product and production, deluxe, fine, and ordinary. Deluxe is 15, 14, 19, 18, and fine is 17, 12, 20, 16. Ordinary is 16, 18, 16, 17. Is there a significant difference in the prevalence of the product test using ANOVA test? And one thing more, use alpha equal to 5%. Here in question this is given, alpha equal to 5%, and we can know about the something ANOVA test. That is, ANOVA test is a random sample and more than three variable we can determine by this we can find, and this is normally distributed, and the variance and the population are equal, and every sample are independent from each other. That is, every sample are independent from each other, never is dependent. So we can solve this question by stepwise, and that is step 1, that is setting of hypothesis that let mu1, mu2, and mu3 be the population mean of the product of deluxe, fine, and ordinary. Now after this we can go, that is mu1, mu2, mu3, that I told from first of all, variance and the population are equal, and that H1 is not all the means are equal. After this we can go to the step 2, that is calculation. Calculation is x1 minus x1 whole square, that is the table, and x2 minus x2 mean whole square, and that is x3, another x3 minus x3 mean whole square. After this we can find a value, that is 15, 14, 19, 18. 15, 14, 19, 18, and for x2 17, 12, 20, 16. For x3 16, 18, 16, 17. And for n1 value, every value is 4, n2 equal to 4, n3 equal to 4. Now we have to find sigma x1, and by the adding this all we will get 66, and after this mean 1 x1 will be 16.5, and by this in x2 will be 65, and x2 mean will be 16.25. in this x3 will be, summation of x3 will be 67, and x3 mean will be 16.75. and now this we have to calculate this x1 minus mean x1 and whole over whole square. Then by this we will find this value 6.25, 2.25, and after this we will get summation of this, that will be 17, and after this we will find this 5625, 18.0625, 14.0625, 0.0625, and that will be x2 minus x2 mean whole square, then that will be value 32.75. now this, and 0.5625 0.5625, 0.5625, 0.0625, and summation x3 minus x mean 3 whole square will be 2.75. Now by skipping this all, we can find now capital N equal to N1 plus N2 plus N3. That will be 4 plus 4 plus 4 will be 12, and k equal to sample variable is 3. And now we can take from this N1 equal to 4, N1 will be 4, N2 will be 4, N3 will be 4. Now x1 mean will be 16.5, we can take from this, and x2 mean will be 16.25, and x3 mean will be 16.75. Now we have to find combined mean. And combined mean will be, the formula of combined mean, N1 x1 mean plus N2 x2 mean plus N3 x3 mean by N1 plus N2 plus N3 all equal to capital N. Now here we can find 14 into 16.5 plus 4 into 16.25 plus 4 into 16.75 divided by 12, and the value will be 16.5. Now we have to find SST, and that formula will be 4 into 16.5 minus 16.5 whole square plus 4 16.25 minus 16.5 whole square plus 4 16.75 minus 16.5 whole square, and that will be 0 plus 0.25 plus 0.25, and overall this value will be 0.5. Now we have to find, and now we have to collect the value from this again, this value, and this value. That will be summation x1 minus x1 mean whole square will be 17, and summation x2 minus x2 mean whole square will be 32.75. Again summation x3 minus x3 mean whole square will be 2.75. Now we have to find SSE. That will be sum of this all three, that is 17 plus 32.75 plus 2.75, that the value will be 52.5. Now we have to find ANOVA table. ANOVA table will be source of variation, degree of freedom, sum of squares, mean sum of a square, and EF call. Now here will be treatment and error. You can make the table like this. Here is degree of freedom is k minus 1, that is k value is 3 and minus 1 is 2. Then n minus k equal to, that is 12 and minus 3 is 9. Now sum of square will be SST. SST will be 0.5, and SSE will be 52.5. Which value? Now mean of square will be MST will be 0.25 and MSE will be 5.83. Here we find this by MST we found by 2 divided by 0.5. Divided by 2. Here we found from this SST 0.25 and 52.5 divided by 9. The value is 5.33 and 5.3. I wrote. And now we have to find F call. F call will be MST by MSE. That is MST value is 0.25 divided by 5.83. That is 0.00428 mean 0.043 we can write. Now by removing this we can move to step 4. Here is step 3. Now we go for the step 4, and step 4 will be tabulated values and their graph. Now the graph, first we have to find F tab, that is F2 and 9, and that is the from graph we can find the value, that will be 4.2565, and here is the sorry for the inconvenient disturbance, and here is the value is 4.2565, so we can take the value here 4.2565. so here will be rejection and here will be acceptance. So here we can see that 0.043, our obtained value is 0.043. Here is the F call 0.043. So 0.043 lies on the acceptance region A of graph. We accept H0, that is we are 95% confident that there is no significant difference in the preference of product. So here we end with this solution, and this is overall our today solution. So thank you.